All right, everybody, let's take a look at what we're going to call dividing polynomials. Yay. So there are times whenever we have, basically the idea is we might have a really large polynomial, like a trinomial or quadrinomial or something like that. And we need to get that thing down to a quadratic. Because if I have a quadratic, as we know, there's lots of ways that we can work with quadratic. So what if you have something that is x to the third or x to the fourth or even bigger, and you want to find the solutions. And like we talked about the other day, when we say find the solutions in our math brain, hopefully that means find your zeros or find your roots or find your x-intercepts, anything like that. Those would be great, right? So that would be considered my solutions. Okay, those are all the same, different words for the same thing. Excuse me. So what we know is this. For a quadratic, we have lots of ways to solve those, right? You can find your solutions, and we know for a quadratic, that's x squared, right? So I can find my two solutions. Because it's x squared, I know I should have two solutions by factoring or square root property, depends on what the problem looks like, right? Like if it was x squared equals 16, something like that, I can just square root both sides and I would get plus or minus square root of 16, which is 4, right? So that's applying the square root property. We've done that before. Or maybe I can use the quadratic formula. Or I can complete the square. Those are the normal ways we might be able to solve a quadratic, okay? The square, not squares, okay? Complete the square. Okay, so there's lots of different techniques that we can work with once we get something down to a quadratic. The problem is if it's x to the third or x to the fourth or something like that, I don't know what to do with those, right? Okay, so I'm just like, oh no, what am I supposed to do with something that's that large? And the idea is that we know, like if it was x to the fourth, that it would have something that is a factor, basically, that I could pull out. And if I have something that's a factor, then I could rewrite this. So let me give you an example. So I think, and I just kind of threw this one together on the fly, so hopefully this one works for us. If I tell you you have a function and the value is x cubed plus 5x squared plus 7x plus 3, okay? If I give you that and I say, hey, look, I know that this is x to the third, and we're not able to do anything really with x to the third, but I say it has a factor of x plus 1, okay? Then what I'm telling you is, hey, look, I think that you can divide out an x plus 1. Well, if I can pull out one factor of x plus 1, that would reduce this by an x. So then I would have something that's x squared, and then I could factor that or use quadratic formula or something to that effect, right? So the idea is, hey, look, I've got this big polynomial. It's x to the third, and I have one factor that I think will go into it, okay? Or I might tell you, hey, I found a solution to this. I know if this is a factor, then I know that x equals -1 would be a solution, right? So, because I could set this equal to 0 and solve, okay? So I might tell you, hey, look, this guy. But the problem is you've got to do some math to be able to get this guy from x to the third down to x squared. And that's where our topic for today, dividing polynomials, that's where that's going to come in for us, okay? So the idea is there's a couple of different ways for me to do dividing polynomials. And we're going to do it the normal kind of long-handed way first, which is long division. Okay, so I can do long division with this. And you've seen long division with numbers, but maybe you've never seen long division with polynomials. Okay, so that's what we're going to do. Okay, I've got my function, x cubed plus 5x squared plus 7x, and I'm going to divide it by x plus 1. Okay, that's the idea. So if I was doing this with numbers, okay, let's do 126 divide by 3. This is just scratch work off to the side. All right, it's just a little aside. If I wanted to do that, then what we'd say is take this 3 and will it go into 1? No, but it'll go into 12, right? 3 goes into 12 how many times? You tell me a 4. So you figure out how many times first, and then you say 4 times 3 is 12. And the kicker here is we would subtract minus. All right. So once I subtract that, that goes away. And then I bring down whatever's left over, 6. And I say 3 goes into 6 how many times? And you guys say 2. And 2 times 3 is 6. And then remember, the process here is going to be subtract. And when I do that, that's a 0. So 3 goes into 126 exactly 42 times, right? No remainder, no nothing like that. It's just, it goes in 42 times, okay? So we're going to use a similar process for dividing our polynomials, but what we're going to say is, okay, we're only going to look at the first term. We're going to consider this like the rest of the stuff, the 2 and the 6 or whatever. And we're only going to look at the first term out here. So what I'm going to say is x goes into x cubed how many times? And if you're not sure about that, you can come down here and do a little, again, side work, okay? X cubed over x, it's really x to the first, right? So x cubed over x, you can either cross one of them out and subtract 1 from the exponent, or you can use your little exponent rule that says x to the 3 minus 1, because it's a 3 up here and a 1 there. So either way, hopefully you can see that x to the third divided by x is x squared. So x will go into x to the third, x squared times. Okay, that's my answer on the top. Okay. And then we're going to do it just like we did over here. We did 4 times 3 is 12. So now I'm going to do x squared times x is x cubed. I'm going to multiply that through. Let me kind of do this like this. Okay. I can't stop with just the x cubed because I need to multiply it all the way through. So it's x squared times x is x cubed, but then x squared times 1 is plus x squared. Okay, that's what this term on top times everything on the outside is. Okay, and then here's the big thing. What did we do here? We went 12 minus the 12, right? So I've got to come in here and I've got to subtract everything that I just put down here. And so it's a minus here, and a lot of people remember that one, but they forget to do a minus here. So it's on both terms. We are going to subtract. Okay, so make sure that the negative goes all the way through whatever you have down here at the bottom. All right, x cubed minus x cubed, that should go away. If I've done things correctly, that first term is now gone. Okay, and then 5x squared minus, it's really a 1x squared, right? 5 minus 1 is 4x squared. Okay, that's what's left over. Okay. and then bring down the rest of the stuff, right? Like I brought down the 6, just bring it down. So I'm going to rewrite the rest of this stuff, which is right here, plus 7x plus 3. Okay. All right, so now what about it? We're going to go, we don't have this x cubed guy anymore. So now we go to the first term here. Okay, 4x squared divided by x. Well, 4x squared divided by x. X goes into x squared, 1x time. And x goes into 4x squared. Hopefully you got the 4, right? So you can check yourself here. 4x is what I think this is. If we did it right, the 4x times the x should give me a 4x squared. So try to check yourself there and make sure you got all the pieces. You need something for the coefficient, the number part, and you need something for the x part. So I only had 1x, I needed x squared. I have to do x times x to get x squared. And I only had a 1 sitting out here in front, but I need a 4, right? So if I need a 4, 1 times what gives me that 4, right? So hopefully you're saying to yourself, 1 times 4 gives me that 4. So it's going to be 1 times 4 gives me that 4, right? Okay, so 4x times 1x gives me 4x squared. I do have the same thing. That's what I'm going to want, right? But remember, I can't just stop there. I have to distribute that 4x through. So I do it there, and I multiply it by the 1. So what's 4x times 1? It's just a 4x, right? Okay. So there's only 2 terms out here. I should only have 2 terms here. We're good. Remember that though, what am I going to do here? I don't add these. I need to subtract these. So remember we changed both signs there. I'm going to change both signs here. Okay. Hopefully when I'm finished, the 4x squared and the 4x squared, those guys will reduce. They go away. Here I've got 7x minus 4x gives me 3x. Pull the 3 down. Okay, pull anything down that's still sitting there. So I've got a 3x plus a 3. And it looks like we're almost there. We're doing good. So I just need to know what times x or 1x gives me 3x. So in my head, I'm thinking, well, I need to multiply it by 3, right? 3 times x gives me 3x. Okay, and then don't forget that you have to distribute that 3 through. So all the way through, I got to go to the 3 times the 1. So I've got a 3x plus a 3. And look at that. Hopefully we get exactly something like that. When I subtract, remember to change both signs. Both of these will go away. Okay, then I get a 0. If I get a 0, 0 remainder means what? That factor went in evenly, right? If it didn't go in evenly, I'd have some other remainder, like maybe a 3 or a 4 or something like that. But when nothing is left over, that means that whatever I put in here, the x plus 1, went very nice and evenly into the overall thing. So here's what we say. This is what it looks like. Remember the original problem was x cubed plus 5x squared plus 7x plus 3. And we divided it by x plus 1. I'm going to put parentheses so we can see both of those guys. Okay, that's the process we were doing, all right? And what we got was whatever is on top, that's my answer, right? That's equal to x squared plus 4x plus 3. Okay. And it happens to be no remainder. It better be no remainder because we thought that this was a factor. If it is a factor, then you will always get a 0. That's my remainder. If I get some other remainder left over at the end, that means that this guy's not a factor, right? So what this tells me is I can rearrange this, okay? Here's my original, x cubed plus 5x squared plus 7x plus 3. What we're saying is I divided by this guy, but I can rearrange this so that it looks like whatever my answer was, x squared plus 4x plus 3 times, because the opposite of division is times, so I can multiply this and get it on the other side, times the x plus 1, okay? This is this guy factored, okay? And I did it by doing long division. All right, that's what I was after, yay. Okay, so hopefully we got that far and I can see it. Now what? Okay, now I'm looking at this guy going, okay, I've got a quadratic. Will this guy either factor or can I use quadratic formula, something like that? So I want to know, can I factor the rest? Because I actually made out this problem very nicely so that it will factor. What we're going to end up with is x plus 1, because that was the guy I divided out, right? He's just going to sit there. And then this will factor x and x. And I need factors of 3 that add up to 4. They're all positive. So we get all positives down here. That's good. That's the easier factor, right? There are more difficult factors than this. And then to get a 4 in the middle, I need a 3 and a 1. And you could put that either direction, right? You could have said x plus 1 times x plus 3, however you want to, okay? So what we've got here is, this is the same as my original function, okay? It's just in factored form now. And we like these things to be in factored form. Now it's got 3 factors. And by the way, because I started with x to the 3rd here, we hope we have 3 factors, right? Because we should have 3 solutions. Remember that from the other day? So 3 solutions. That's what I should be getting. We'll see, because what I need to do to find those, remember finding solutions is the same thing as finding x-intercepts. And to find an x-intercept, what we do is we plug in 0 for your y, or in this case, that's my f of x, right? Okay, so what we're going to do is we're going to say, okay, well, cool, 0 equals x plus 3 times x plus 1 times x plus 1. And we like that guy because it's easier to set my factors equal to 0, right? So here I go, x plus 3 equals 0, or x plus 1 equals 0, or x plus 1 equals 0, okay? So hopefully this turns into something that I can do. Solve these 3 pretty quickly. I'll subtract 3, right? Over here, minus 3, and I'll end up with x equals -3. That's one of my solutions. Or here, I need to subtract 1, minus 1, minus 1. And again, I end up with x equals -1. Or same thing here, right? Because it's actually the same factor. I didn't necessarily point that out earlier, but it is the same factor. So minus 1, I get x equals -1, okay? So I do have 3 solutions here, but what about the one solution, this guy? Remember multiplicity? X equals -3 has a multiplicity of 1. It only happens one time, right? Okay, but x equals -1 has a multiplicity of 2. Okay, so that means to me, hey, that one is going to, basically the solution happens twice, right? Multiplicity of 2. But remember what we said the other day. If we have a multiplicity of 1, when I go to graph this guy, I will have an x-intercept that just passes through. If I have I'm sorry, a multiplicity of 2, then that guy is going to be something that bounces, right? So let's get this guy into my equation in my graphing calculator and see if we can do this. We have x to the third plus 5x squared plus 7x plus 3. Okay, so let's see what that looks like. All right, so it does have where, hey, look here at the -3, we passed through. That's what we expected to happen, multiplicity of 1. Okay, but here at the -1, it had a multiplicity of 2, so you can see it's bouncing there. Okay, it comes down, it hits it, and it goes back off. And all the other stuff that we talked about the other day should still come into play, right? This is an x cubed, it's an odd function, so it's starting at the bottom. Hang on. It's an odd function, so it's starting at the bottom, it comes up, it does some stuff in the middle, but the end behavior of an x cubed that has a positive out in front of it is it starts at the bottom and it goes to the top, right? So hopefully that looks about what we expect it to look like, and all the stuff we've already learned still holds true for us, right? So nothing weird happening there. All right. So I'm going to give you one to work on, and let's see if you can work it out. So this one is, it's a little bit different than the last one we did, but hopefully it'll work out for us. So here we go. We'll see how it goes. We're going to do 8x cubed minus x plus 2 divided by, and we're going to do 4x squared minus 1. So it's not going to look quite like the last one because on the outside I had just divided by x plus 1, right? Okay, here we're dividing by 4x squared minus 1. So I'm actually going to pause my video for just a second. I'm going to work it out. If you want to pause the video so that you can work it out, then we'll come back and compare. So let's see how that looks. All right, so hopefully it didn't take you very long. You look at the 8x cubed and you say, hey, I'm putting 4x squared into that. I'm missing an x, so I need an x up there, and 4 times 2 gives me the 8. So double check yourself, 2x times 4x squared should give me 8x cubed, okay? So write that guy down, and then don't forget that you need to distribute. This times this, this times this. So I also have to do 2x times -1, which is a -2x, right? Okay, I've got that there in black, -2x. But then remember that you have to change your signs. You have to subtract for these to go away, right? So I need a minus here, but I also need a minus here, but it was already 2x times -1 is negative. So when I go to subtract a negative, that becomes a positive, right? So that's why I've got it like that. Okay. These guys go away. -x plus 2x is x. Okay. Bring down the 2. So I've got an x plus 2 down here. Will 4x squared go into x? And hopefully the answer you have is no, because this is x to the first, and this exponent 1 is less than the x squared. So I can't divide x squared into x and still keep like a polynomial, right? I would end up with some weird x on the bottom kind of stuff. So this is my remainder. Okay, so my question is, does 4x squared minus 1 go evenly into 8x cubed minus x plus 2? And the answer is no. So 4x squared minus 1 is not a factor of the original, right? 8x cubed minus x plus 2. Sorry, I'm move it up here. Okay, so no. If I don't get a 0 down here, then it is not a factor. And so this is not going to work for me. Now, this is not an in vain effort, though, because later on, when we start talking about rational functions, okay, we're going to talk about something called asymptotes, okay? And when we get to doing that, we will have to do this exact same process to get to whatever's going on down there to get an equation of a line. So I'm going to use something like this later. So don't think, oh, that was just wasted effort. It's not. We found out that this does not divide evenly into there. We have a remainder, and we found out that we've got an x plus 2 as the remainder. So those are both going to be helpful things later. All right, so just real quickly, if you have something that has a remainder other than 0, remember that that means we do not have a factor, okay? That's where we're headed for that. Okay, then we got another kind of division, so we need to talk about it. Synthetic division. Okay, when we go to do synthetic division, there are actually a couple little rules that I have to adhere to about synthetic division. So let me get you an example real quickly, and then we'll show how to do synthetic division. What is synthetic division? What it is just an easier way of me doing some kind of division without having to write it up as this long division kind of thing, right? We have that long division we were saying. So here's what we're going to do. We're going to do x cubed plus 4x squared minus 5x plus 5, and we're going to divide that guy by x minus 3. Okay. Now, here's what has to happen in order for me to be able to do synthetic division. Synthetic division basically says, I'm going to write this as a division problem, and I am going to not use any x's because sometimes the x's bug people, okay? So in order to set this up, what I need to do is I need to look at the guy I'm dividing into, okay? And I need to say, hey, what are all the coefficients? Okay, that's the number out in front, right? Like there's a 1 in front of this guy, even though I'm not writing it. So I've got a 1x cubed. Leave a little space. I've got a 4x squared, leave a little space. I've got a negative 5x, and I've got a positive 5. So my coefficients up here are 1, 4, negative 5, 5. And whenever I look at those, the only thing I have to be really, really careful of is don't skip any exponents. Okay, don't skip any exponents. So what I mean by that is, what if they had not had this negative 5x guy here? Okay, they just had x cubed plus 4x squared plus 5. Okay, and I don't have anything there. Then I can't skip this spot. I need to have a placeholder. So if there aren't any x's, then I would have 0 x's. So if they skip one, you have to think, oh, hang on, I got to stick a 0 in there. Okay, so you need a placeholder for everything. So this was x cubed, this is x squared, this is x to the first, this is no x's. These are just constants, right? Okay, so that's the first thing for setting one of these up. And then you'll have a little box out here to the front. Skip a little space and draw a line underneath. And the second thing you got to be able to do is, instead of using this factor, we're going to find the solution. Okay, so the factor looks like x minus 3, but the solution would be whatever this is when I set it equal to 0, right? So I know that x minus 3 gives me x equals 3 as my solution. Okay, so the solution is the actual x-intercept. What is that point? What's the x value? Okay, the factor is when it's in parentheses with x minus or x plus or whatever. Okay, so inside the box here, I'm going to put the solution, which is positive 3. So here's the thing about synthetic division. Okay, some people are like a little confused at the beginning. Just remember, we're going to do the same process we just did for division, but without all the x's. So it might be easier. Some people think it's easier. Here's the reason why it's easier. Instead of doing a lot of subtraction, we're going to do, multiply and add. So I pull the 1 down. It goes underneath the line. And then I have to have a starting spot, right? So whatever the first guy is, pull him down. And then I've got 3 times 1 gives me 3. So I write it up here, okay? Multiply. 3 times 1, that gives me 3. That goes above the line. And then the process is we add. 4 plus 3 is 7, okay? Multiply. 3 times 7 gives me a 21. That goes above the line. And then we add. So it's just multiply, add, multiply, add, multiply, add. So 21 plus a negative 5, that's 16. Okay. Now multiply 3 times 16, that's 48. And add. Okay. 48 plus 5, that's 53. Okay. So that gets me through the process of doing the synthetic division. Whatever this number is right here, that's my remainder. Okay. So what we know is x minus 3 goes into this guy. I can rewrite this if I want to. The interesting thing is, remember, it was x to the third. I pulled out 1x. So these should be 1 fewer exponent, right? So this is going to turn into 1x squared plus 7x plus 16, remainder 53. Okay, that's what we get when we divide that out. Okay, so if the remainder is 53, the question is this a factor? Is x minus 3 a factor? Question mark. And the answer is no. Okay, remainder 53 is not a 0. If I have a remainder of 0, then I have a factor. But I do not have a factor because this is a remainder of 53. So it's not going to work for me. All right. Okay, so that's how I know what's going on there. We're going to do one just to make sure everybody's okay. Let me try to find you one that turns out fairly nice and easy. How about, here's my example. 2x cubed minus 3x squared minus 11x plus 6. And we're dividing that sucker by, let's just say divide by x minus 3. So it's actually the same number. Sorry, I didn't realize it was the same exact, the same factor. Okay. But you should still be able to do the process here and make sure we can line it up. So 2, negative 3, negative 11, positive 6. Double check that we have all of our exponents. We've got a 3, a 2, a 1, and none. So we're good there. And then what goes into the box? And then leave yourself a little space and draw a little line. So if you need to pause the video so that you can play with it for just a second, you can. What is the solution that goes in here? It's a 3. All right. So now I'm going to run through this pretty quickly. Bring down the 2. 3 times 2 is 6. Add 6 plus negative 3 is 3. Multiply 3 times 3 is 9. Add again 9 plus negative 11 is a negative 2. And 3 times negative 2 is negative 6. And we like it when this happens. 6 plus negative 6 is a 0. Remainder 0. We like that, right? Okay, what does that mean for us? This is a factor. Okay, so that means if I look at this guy, I ought to be able to bring this down to a quadratic. So what does this equal? The original guy was 2x cubed minus 3x squared minus 11x plus 6. He's equal to, we pulled out the x minus 3, right? That's the one factor we pulled out. And what's left over? This guy, 2, but he's not an x cubed anymore because I pulled out an x already. So he's 2, subtract 1 on your exponents, x squared, right? And this guy was 3x squared is where he was coming from, but he's not an x squared anymore. He's a plus 3x, and he changed to positive while he was down here, right? And then the minus 2. So an x squared, an x to the first, and no x's. That's how that'll factor out, okay? So we're going to use either long division or synthetic division to be able to pull these guys down. When we get a factor or a remainder of 0, we know we have a factor. Now this guy, maybe you can factor him, maybe you can't, right? So maybe you go ahead and worry about that. It actually does factor. If it did not factor, then you would have to use the quadratic formula to try to find your solutions, but this guy should be okay. I'm looking, this is 2x squared, that's 2x and x, right? And I know I've got a -2 in the back, so one's a positive and one's a negative. It actually ends up being -1 plus 2. All right, so now if they said something like, find the solutions for this cubic, we can do that, right? Find the solutions. We've already done that before, so just take everyone and set it equal to 0. X minus 3 equals 0, or 2x minus 1 equals 0, or x plus 2 equals 0. So solve those up as best you can. We need to add 3 here, so I'm getting x equals 3. Show the in-between steps if you need to. Maybe on this one we need to show the step, right? +1 + 1, because there's an in-between. 2x equals 1, and then I need to get the x by itself, so divide by 2. X equals 1/2. Okay, or this one is what? Subtract 2. X equals -2. Okay. Those are my 3 solutions. Okay, I've got a 3, a 1/2, and a -2. All right. So hopefully we can use all these things to help us see stuff. The one last thing that I want you to know about this section is, before we start doing other stuff with all of this later, that we have something that's called the remainder theorem. Remainder theorem. Okay. And what that remainder theorem says is, if you are doing your synthetic division or your long division, whichever way you want to do it, and you come down to it and you find that you have a remainder, okay? So let's say we have a polynomial function. We'll call him f of x, divided by, and they always write it kind of like a factor where we don't know what the number is in here, but let's say x minus c, okay? Where c is the possible solution. Because if I solved this, I would have x equals c, right? If I set that equal to 0 and solved it, okay? Where c is the possible solution, then we can find the remainder by using f of c. Okay, we can find the remainder by using f of c. So what does that mean? You've got this polynomial function and you think, hey, x minus 2 might be a factor. Maybe 2 is the solution, okay? If you want to know for sure if it's a factor, if that's a solution, then you substitute it into the original function. Okay, so let's go back up to this one that we had. We're just going to use the one we already had, is for a solution for 2x cubed minus 3x squared minus 11x plus 6. That's the question. There's my f of x, okay, is for a solution. Well, first of all, we know it's not because we already found the 3 solutions, right? This is a cubic, so it only has 3 solutions possible, and we found all 3 of them. 4 wasn't one of them. But if you haven't worked this problem yet, you don't know that, okay? So what would you do? You come up here, you find your f of x, and you find f of 4, okay? So if I plug that f of 4 in, then I've got 2 times 4 cubed minus 3 times 4 squared minus 11 times 4 plus 6. Okay. Well, 4 times 4 is 16, and 16 times 4 is 64. So this is 2 times 64, I'm pretty sure, minus 3 times 16, minus a 44 plus a 6. And I'm not sure what that is, but it's a pretty big number. Let's check it and see. 2 times 64, well, that's 128, right? Minus 3 times 16 is 48. Minus 44 plus 6. So minus 48 minus 44 plus 6. Okay. This is equal to 42. Okay. I don't really care what the remainder is unless it's 0, right? So this is not a 0. Okay, which means 4 is not a solution. Okay, so why would I care about that? Okay, let's say we were working the problem we had before, okay, and they said, take this guy and divide by x minus 3. And maybe they're asking you, is this a factor? Will it, you know, can you find the solution, whatever? Well, before I go and do all the long division or the synthetic division or whatever I'm doing there, it might help me if I use my remainder theorem, right? That we just figured out, okay? So same function, f of x equals 2x cubed minus 3x squared minus 11x plus 6. But we know that this guy, x minus 3, is a factor. X equals 3 is a solution. So let me stick in f of 3. 3 cubed minus 3 times 3 squared minus 11 times 3 plus 6. So if we're right, we better get a what here? F of 3 better be equal to 0 when we're finished, right? So this is 2 times 3 squared is 9 times 3 is 27. 3 times 3 squared is 9 minus 33 plus 6. Okay, 2 times 27 is 54 minus 27 minus 33 plus 6. Here we go. 54 minus 27 minus 33 plus 6. Look at that. That's a 0. Okay. So I might, unless they just tell me that that guy is a solution. Oh my goodness, hang on, sorry. Unless they just tell me that 3 is a solution, I might go ahead and plug in the 3 and see if I get out a 0. If I get out a 0, then hey, now I've got a remainder of 0. I know that thing is a factor. Now I can use it, okay? So then that might save me a few trips to the long division and the synthetic division, right? Because I know I'm going to get a 0 here. If I don't get a 0 here, I won't get a 0 here, okay? If I do get a 0 here, I'd better get a 0 here, okay? So that makes my life maybe easier because maybe I don't spend extra time doing long division or synthetic division that I don't need to do, okay? So I think that's it for this particular section. You should be able to do dividing polynomials in your homework now. They might tell you, yeah, so you might end up with stuff like what we just did a second ago, where they say solve the equation if you know that 3 is a solution, or if you know that 3 is a 0, or you know that 3 is a root. Okay, and it's not always going to be 3, right? I just happened to pick 2 examples in a row where we had a solution of 3. Actually, I think one of them was -3 ended up, right? So anyway, that's it. I hope everybody has a good day. Thank you so much. Let me know if you got questions.